A very good evening to all of you, and it's a new initiative. We are starting with a new series of actual training videos. So this one is just a demo or actual video from our series of RHCE trainings. So it is a part of our RHCE training videos, and I've just taken this particular video from or the topic from our module SA1, which is obviously the first module as far as the RHCE training is concerned. And here I'm going to explain you unit 5, that will be managing your physical storage. So it is another step that we intend, and we are planning to have videos like this, all these videos which will cover the topics those are a part of the RHCE curriculum, and we intend to share you more apart from what is being specified in the official courseware. And obviously down the line these videos will be paid, or you need to subscribe to these videos for the whole RHCE training. But by this video you will get a idea of what kind of standards or the quality or the contents we are planning to put in these kinds of videos. So in this video I'll just start with the things that in this video I will be covering unit 5, managing physical storage. So what we intend to do, we will be like exploring number 1, how to create partition. Number 2, how to create file system on partitions. Number 3, we'll be covering how to use them, or how to mount or use them manually. And 4th, we'll be seeing or learning how to mount or use the file systems using etc fstab for automatic mounting. And then in the last, though it is not a part of your RHCE training, but I'll be explaining you, or we'll be checking here then how to change the properties of the file system. How to change the properties of the file system, that is very important. How to see and change the file system properties. So this is what I intend to cover in this video. So the first thing is that we need the partitions. Why we need partitions? We need partitions because we need to have more storage. We need to store some data separately. So I can just point out key points. I can point out that okay, I can just put it like this. 1, we need partitions. Sorry. When our storage needs are defined and is never going to change. That means we have got fixed storage needs. Fixed storage needs. If you want to have a flexible storage that you will be able to increase the size of your storage, then we will be looking for the next level or the next topic of our RHCE training, that is the LVMs. But I'm not explaining the LVM here. Let me do it like this, so it will be much more easier for you to read. And let me press enter here. Fixed storage needs, that is great, that is good, fine. And one of the key benefits of the partitions is that it's easier to create and manage partitions. Thirdly, as I told you, as a rule, always keep your sensitive or important data or files on a separate partition. Now, there are two ways to create a partition. Point number 4, there are two ways to create partitions. I can put it, number 1 is I can use the graphical tool using the GUI, and second is using CLI, command line interface. Now I'll show you both things, that it is my virtual machine for this particular topic. So I can easily go to application, system tools, and use the disk utility to create and manage the partitions. Look, it is here, comes my 21 GB of hard disk. These partitions are already created and I've got approximately 8.7 GB of space free. So I can easily go down here, click on create and do the things. That is fine, no doubt. Fine. So means for the GUI, I can just go to application. Then I can go to system tools as I shared with you, and then disk utility. And then disk utility. That is fine. But, and using the command line, which we normally prefer, or which the Linux admins always work with the command line, I can use the fdisk or I can use parted. These are the two commonly used tools to create the partitions using the CLI. But I personally recommend or prefer using fdisk. Prefer, I can just write here PS, a point here, I can just put it like this. Prefer using fdisk. There is a very small reason. A good reason to use fdisk is that it is always available. That it is always available, even in rescue environment. So that is why I personally recommend you that you should get expertise on the fdisk rather than on the parted, because fdisk will even work in the rescue environment. If you are not familiar with that what is a rescue environment, then you need to wait for our next videos, or if you are comfortable or you are known with the rescue environment thing, then the topic or this particular point will be handy to you. Now let's move further. There are three kinds of partitions that I can create. Three kinds of partitions. I can put it as they say. Number 1, I've got a primary partition. Now what is a primary partition? I'll just make it in a very simple points and a straightforward points. The first thing is that you can have a maximum of 4 primary partitions. Sorry. And one of the important feature or the characteristic of a primary partition is that it is written directly to the master boot record of the hard disk. Written, I can just mention it for you, written directly to the master boot record of the hard disk. That's good. Now second, we have got something known as extended partition. Now extended partition is that because there is a limitation on the primary partition that you cannot have more than 4 primary partitions. So if you have created 4 primary partitions already and still you have got some GBs of space already free on your hard disk, then you cannot use it. So we have found out a way of using or creating more than 4 partitions in the hard disk by using the extended partition. So every hard disk can have one extended partition. The first point to note is that every hard disk can have one extended partition. Then one of the important points that you need to remember is that you cannot create a file system on extended partition. Cannot create file system on extended partition. Fine. Within the main objective of the extended partition is to create logical partition. So within extended partition you can create logical partitions. Fine. So I will be using or creating the extended partition only when I intend to use more than one party or more than 4 partitions in my hard disk. So I'll be use extended partition when you intend to use more than 4 partitions on hard disk. I hope this is clear. And then I have got something known as the logical partitions. Now logical partition is created, the first thing that should be there in your mind very firmly is that it's created inside the extended partition, and you can have a maximum of 11 logical partitions per disk. Fine. So now we have just learned about all these things, that we have got 3 kinds of partitions: primary, extended and logical. Now the next thing is that while creating the partition, after we select that what kind of partitions I am intending to create, whether I am planning to create a primary partition or extended partition or a logical partition, then I need to select, after this I need to select the partition type. So the 6th point I can mention is that after selecting between primary partition, primary or extended or logical partition, I need to select partition type. Now what is the partition type? I'm not writing here all the available partition types. I'm just specifying here or mentioning here common partition types. Common partition types are, I can write it as, say, one is, we've got some code associated with the partition. 83 number code, it is the default one, default partition types, and is used for any partition that is formatted with Linux file system. It is the default one. Second very commonly used is the swap. So 82 is the code for the swap. I'll just show you all these things. Then 05 is for extended, as I explained you about the extended partition. And then because we will be covering the LVM in our next video, so I can just give a small mention of LVM here. 8E will be the code for the LVM physical volume. Let me show you. If I just go here on my machine and I just give a small command fdisk-l, you can see there 83 is for the normal Linux partition and 82 is for the swap. Because I have got only 3 partition, not 4, so you are not seeing extended one, so which I will be showing you in the video. Now let's move further. Now let's see how to create a partition and how to move forward. Now the first thing is that before creating the partition, you need to choose your hard disk, that on which hard disk or on which device you want to create a partition. So the first thing is that I can put it on point number 7 here. Check the device on which you intend to create partition. So for checking, a very simple command can be dmessage. I'll show you. To view your device, I can just have a small mention here for you. So I go here, though it can be easily available with the fdisk-l command, as you can see there that my device right now is SDA, but there is no harm learning couple of new things. So I give dmessage pipe grep -i sd -color. So it gives me some output. So I am more interested in SDA, attached SCSI disk, and these are the partitions. So with dmessage, I came to find out that I've got only one hard disk attached, which is the SDA. If I've got another hard disk attached, then it will be coming as SDB. So, but in this case, it is not. So first thing is that it is always recommended to check your device by using the dmessage command. And point number 8, it's very important as well as dangerous. If you are sure, after you are sure about the device name, in my case it's dev SDA. Might be you wanted to format a pen drive or a external hard disk, so you need to make sure about the device name. So after you are sure that okay, this is the device that I intend to format, or I want to create partition, if you wish, you can use dd command to wipe out all the things. You can use dd command to wipe out all the contents of that device. But I will be using this command, so I can easily give, in my case I can give here ddif is equal to /dev/0 and of is equal to /dev/sda. But a simple alert is there. Issue this command only when you want to wipe out everything on that device, and there is no rollback after this. Fine. So you have to be very careful, otherwise please skip the point number 8. No problem at all. Now after I had found out my device, that my device is SDA, and I'm uh, here in for this video. I have no plans to issue this particular command. Now what? Simple. I can use, now I'll be just going on to the actual practical steps. I can use fdisk command. Use fdisk/sda to create new partitions. So let's move and do this. So first I'm going to create one primary partition for you, and then I'll be creating one primary partition of say size 500 MB, more than enough. And then I will be creating one extended partition, and inside it, okay, let's do the first thing first. So here goes the lab. So I give here fdisk-l, and by this command I came to find out that my device is SDA. It is of 21 GB of size, and the tracks and sector information is coming up right here, and these are the partition types coming available here. Fine. So I give the command fdisk-cu/dev/sda. So I'm intending to create a new partition. So press enter here, M for help, no problem, just press M here. I'm pressing the M. It gives me a very beautiful menu driven option here, that these are the shortcuts available for the action which is known. So because I intend to create a new partition, I'll be pressing N here. So N, enter. So what, because I have got less than 4 partition, that is why the fdisk is prompting me that whether you intend to create extended partition or a primary partition. You can very clearly see here that it is mentioning 1 to 4. So I here intend to create a primary partition. So I press P here. Let the first sector at the first sector, just press enter here. So it will be the starting point. The starting point will be the ending point of the last sector or the last partition. And then you have got an option of, I can just make it more bigger for you, like this. You have the option of specifying the size here in KB, K, M and G, KB, MB and GB. So I here give plus 500 M, enter. Job done. Now if I press M once again, that is fine, and I will just give you a print of the partition table. P, look here, it shows me a new partition of 500 MB approximately. The default type is 83 obviously, and the type is Linux. Fine, job done. I press M here again because I don't know how to quit, though I know, but I don't know. So here you can have option coming up here, write table to disk and exit. That is great, that is great. So I press W here, quit. Oh, I'm getting some error or a warning coming up here. Rereading the partition table failed with this error, device or resource busy. The kernel still use the old table. The new table will be used after the next reboot, or you run partprobe or kpartx. The best thing is that now once the partition is created, I can show you here fdisk-l. The new partition is coming up here, SDA4, with the size of 500 MB, which we had specified. Fine, but the point is there, if you see the error message, because the Linux kernel still use the old table. So it is always recommended, I can just mention here, PS, it's a point here, once you are done with fdisk for creating partition, and you see some error, then it is always recommended to reboot the machine so that the new partition will be updated in the Linux kernel. But, and it is what the Red Hat recommends. But you have got other way out also. You can, if you wish. If you wish to skip reboot, you can give the partx command. I can give partx -a dev sda, but the point is that it is not supported. It is sometimes unsupported and there are risks involved, but not recommended and risks involved. So it is always recommended that you do a reboot. Okay, so I will be doing a reboot here, but I'm not doing a reboot right now because before doing a reboot I have another job left for you to create a extended partition, creating a logical partition within a extended partition. So let's do this, and then I will do a reboot which will update both my new primary partition as well as my new extended and logical partition. So I do a screen clear here. I again give this command. I again press M, again press N for adding a new partition. Okay, now says you must delete some partition and add a partition first. Why? Because I already have 4 partitions. So I need to make this an extended one, and then I need to create a logical one. So because I had created the 4 partitions, it won't allow me to create any more partition, though I have got hard disk space left. It is what I intend to show you. So now what I need to do here is that I need to remove a partition number 4. That's great. I do a print here. Now I've got again 3 partitions. Well done. Again I press N here. Now I press E, extended partition. At the first sector press enter, and at the last sector also press enter. So the whole hard disk, whole remaining space will be treated as a single extended partition. That is great. That is great. If I show you, look here, I've got extended partition and the code is coming as 5 as I had explained to you earlier. Now in this extended partition I can create 11 logical partitions. So let's do N here again. Let's look here. Because the extended partition is starting from 249648, so it is starting with this. The default is 696. So I press enter here, and then I give plus 500 N, and then I press a write here, and if I show you fdisk -L here, you can see there then I've got extended partition, and within extended partition I've got a logical partition. I can reconfirm to you by showing you it in the graphical tool. Okay, why it is not coming up here? Because it's not synced. So what I need to do here is I'm just doing a reboot here. Init 6, you all know. Okay, before this I will save this document. I'm saving it on my desktop. RHCE SA1 unit 5.txt. Save. Just close this. Here it is. Now I do a reboot here. Let the machine reboot. In the meantime, you can view my background here, and this conky is running up here. It is just showing me my status or the load on my machine. It's coming up here right now. That's great. Let's wait. Sometimes waiting can be very fruitful. That's good. I'll log in here again. I given my password. I can make it full screen, no issues. Then I open it slightly bigger, go to root, I give fdisk-l, fair enough, and if I show you here, it should be synced here. Look here, within an extended partition I have got a logical partition, fair enough. So now we are done with creating the partition, and let me open my notepad for you, or my whiteboard, electronic whiteboard. That's great. So we had just created the partition. Now what? So the partition creation is done. We know how to create the partitions. These are the points. Now after we had created the partition, the 10th point is that now create file system. Obviously I need to create a file system. That is good. So by default, the point here is that by default RHEL 6 uses ext4 partition or file system, and it is obviously a good choice, and it's good choice. Why? Because one of the, I can make it in points, one of the important, or the one of the say key features of ext4 is that it uses a generaling feature. ext4 is a has a general feature. What is general feature? Generaling is actually a standard in all the modern Linux file system. Generaling is standard now, feature of Linux file systems. But how it helps me? It is actually to understand it in a very say precise manner. General actually works as a transaction log, in which the file system keep records of files that are open at a particular time, open for modification at a given time, at any given time. I can write it like this. So the benefit is that in case your server crashes, the machine knows that which files were open at the time of the crash, and it will immediately indicate that which files may be potentially damaged. Okay, fine, I'll just write it here. The benefit is that in case of server crash, it can check to see which files were open at the time of crash, and immediately indicate, and will immediately indicate that which files may be potentially damaged, and indicate, just a moment, sorry, which files are potentially damaged. So it's a good feature, but there is a drawback also. Drawback is that it consumes some space on your hard disk. Consume HDD space. Though the space is not big, but it consumes space for keeping that general. By average, it is 50 MB on a ext4 file system. No problem. So one thing that is important here to note is that please do not use general feature on small file systems. Fine. Though my partition is also a small file system, but I'm not going to store any data here, so it will work here. Now, how to create the file system? For creating the file system, I can use mkfs utility. Simple, very simple utility. Fine. Now, the first thing is that, now it's a very important point. First thing, the steps involved are, say step number 1, check your device which you intend, on which you intend to create a new file system. So here I can use a fdisk command. So here I can give here fdisk-cul/dev/sda. It tells me these are my partitions. So I can mention here -cul-dev-sda in my case. Feel free to change the device name. So here you need to make sure that I am going to create a file system on SDA 5. Fair enough. So that is great. So in my case it is SDA 5. Step number 2, it's the most important thing. Before creating file system, in my case it is SDA 5. SDA 5 file system. In my case it is SDA 5 on your device. Be double sure that there is no data inside that device. So the easy way is that you need to make sure that, okay fine, it is my server and I have just created the partition, but you might be working on somebody else's server, or somebody else has already configured the server. Now your job is to create a new partition. So how can I be sure that there is no data inside this partition? Because if I give this command, say mkfs.ext4-dev-sda5, and I press enter here, and if there is any data in there, then it will be lost. So I'm pressing a Control-C here. Before giving this command, it's a very small check. Just issue this command sda5 and mnt. It should fail. If this is failing, that means it is not being, there is no file system created on this, and you can safely go ahead with this command. So it's a very small check to find out whether something is there or not. And if there is no error coming up here like this, that means some contents are there, the file system is already hidden, the file system is already there. Then you need to go inside mnt and check whether it is relevant or important for you or not. So I can just mention it here. It's a very important point. Check by issuing, in my case it is mount dev sda5 mnt, and I'll just give a small line. It should fail. If it is failing, that means everything is fine and it's a new partition with no file system. Very simple. With no file system. But in case you didn't get any error, then my dear friend, you need to go inside MNT, which is my mount point, and check for files and folders, and if they are important, don't create file system, or take backup, or do whatever, or take backup first. That is fine. Now once the step 2 is checked, now the step 3 is that once you are sure, then I can issue the mkfs.ext4/dev/sdf5 to create the file system. So let me check it, or issue this command. Now because this mount command has failed, so means it's nothing here, so I give here, I can safely give mkfs dev sd5. Look, the file system is created, job done. Because it was a very small file system of the small partition of 500 MB, it didn't taken any much or any more time. So here it is. So the file system is just created. That is great. Now what? Now if I give the same command, it's working. That means something is there. And if I go here, because it's a new file system, obviously I'm not getting anything, and there are no files and folder. But it is how you should be checking it. Now these things are not available in your standard RHCE curriculum. So that is one of the reasons you should be listening and seeing these videos very carefully. So let's move further. We have just created the partition, job done. Now what? Let me check the, okay, now point number 11. Now I can also change view or change file system properties. It's a very small thing, but you should be aware of these things. Now here you can use, the first thing is that I can write here, you can use the dumpy2fs command to view current file system properties, and you can use tune2fs to change file system properties. I will be showing you both of these commands. That is great. So let me show you a very simple example. Now the file system is created. I can give here dumpy2fs/dev/sdf5 pipeless. See here, it is showing me the file system volume name is none. It is last mounted is not available, and journaling feature is available there. The OS is Linux, inode types, and when it was created, the current date and time, and other things are coming up here. Fair enough. And all these inodes are free. I do a quit here. If you have seen here, the file system volume name is none. Now I will be using tune2fs to assign it a volume name. That is good. So here I'll just give you a very simple example. I can give this command tune2fs-l, the name of the volume, say I give my data, anything, and dev sdf5. That means to assign the volume name of my data to the device numbered dev sda5. Let me give it. So here I give the same command, tune2fs my data dev sda5. Done. Now how can I confirm? If I again give this command, you can see there, now the volume name is coming up here as my data. So in this manner you can use the tune to fs and dumpy to fs to change all or any of the system or the file system properties. So as far as the RHCE is concerned, I'm not going into much detail right now. Now what? Once the file system is created, we have changed and modified the properties like the label, I can mount it. So now the next step is that mounting the file system to use. Now there are two methods. The first method is that I can using the mount command. So I can give here simple mount dev sdf5 and then the mount point mnt. In my case, I can very easily give this command. Or if I am using the label, I can use the command mount label is equal to my data mnt. Both the command. Let me show you. If I give the mount command, right now it is mounted here on mnt. So what I do here, I do a umount here, umount mnt. Then I give the command mount /dev/sdf5 to mnt, and I show you the mount command. It is showing up here, and if I go to mnt here and I create a small file here, say hi. So the file is there, hi. It contains sequence from 1 to 100, fair enough. And I again do a umount, job done. Now if I show you the mount command, it's not mounted, so I cannot see that hi file. So I can use the label also. Label is equal to, if you remember, the label is my data and mnt. Oh, and I need to specify the file system type, so I can use the options here also, but that can be done. Now what? But the point here is that here you are mounting it manually, means after the reboot. The problem with the mount command is that mount points are lost after the reboot. So what to do? I need to mount it permanently. So the second option is that I can use permanent mounting using the etc fstab. Now before I show you how to mount it in the fstab, let's explore fstab. If I just do a cat etc fstab, that's it. If you see there, it contains my file system, that is my root, my boot and my swap. And actually normally people says that fstab contains your file systems. No, it contains your file system as well as your system devices. If you see there, tmpfs, devpts, sysfs and proc, these are your system devices, and these uuids lines, these are your file systems. So I can just mention it here. It is used to mount two kinds of devices. Number one, file system, like I had mounted /boot, I can mount /, I can mount /home, /var, like this. Then the second is that it is used to mount system devices, like I got tmpfs and I had got devpts, if you remember. I had sysfs and proc, fair enough. Now if I show you this, again I do a cat here, it contains 6 columns. 6 columns are there, so we need to understand all the 6 columns. 1, 2, 3, 4, 5, 6. So let's explore all these columns. It contains 6 columns. The first column is the name of the device which is to be mounted. This is the name of the device, the first column. So first column is from left to right. Name of the device to be mounted. Second column, where it is mounted, where it is mounted. That means the name of the directory, name of the location, or you can say directory. I'll just show you. Here it is, that this particular partition is mounted on slash. This particular partition is mounted on slash boot. So it is the mount point where it is mounted. Now the third column. Third column is the file system type. File system used to mount the device. It contains file system used to mount the device. Again, let me explain you or show you. If I go here, look here, ext4, this is the file system which is used to mount the device. Fourth column is the permissions, or we call it the mount options. We use the default to mount without any specific option, which I am using it right now. Now the fifth column, I'll show you. First I'll show you the mount point. This is the defaults, the fifth column, mount options. Then I've got 0, 0. If you see there, then the fifth column is this particular numeric value. If you see there, on my system devices, they are all 0, 0. But on my file system, it contains certain value, 1, 1, 1, 2. So let's understand this. The fifth column, the fifth number, we call it the dump support. Dump support. So we generally make it 1. Make it 1 if you want to. Make it 1 if you just want to want the dump facility, dump backup utility to take the backup, to be able to make backup of this device, which is a recommended one. Recommended. And make it 0 if you don't want it. Simple. If you don't want the backup, simple. So the recommended is the one, and the last and the sixth column is, we call it fsck support. Now here I've got certain values. Use 0 when you don't want, you never want this file system to be checked automatically while booting. Use 0 when you never want this file system to be checked automatically while booting. That is why if you see there, my proc, my tmpfs, my devpts, which are my system devices, are automatically being given the value 0 of fsck, because it's a virtual file system and I need not to check it using the fsck. Use 1. Now I'll be using 1 only for the root file system. So that it will be checked first before anything else. Simple. And then I can say use 2 for other file systems, for all other file systems. So you need to understand this very carefully, very carefully. Now let's mount it in the fstab. If I give the mount command here, it's not mounted currently. What I do here, I create a folder here, mnt say my data, and I want to mount it in this particular folder. So there are two ways to mount the device. One way to mount the device is that I can use the, I can just mention here, two ways to mount device under etc fstab. First way is that using the device name, that is i.e. dev sda5. Let me show you. The first way is this. So I just do a etc fstab. I'll just again confirm it, dev-cul dev sda. sda5 is there. So I do a vim etc fstab. I go to the bottom, I append a line, I give dev sda5. I am mounting it under, my mount point is, I'll just show you here like this, just a moment, here it is. Yeah, that will be good, that will be good. Here it is. Yeah, this is good now. So dev sda is the name of the device which is to be mounted, and I am mounting it under mnt my data, which is my mount point. The file system type is ext4. I'm using the default mount options, and because I want the backup support and I want that it should be checked automatically after the reboot, so I make it 1 and 2, which is recommended one. Fair enough. I save and quit. I give mount all. Mount A is actually the command which will automatically read. So I just use it and issue the mount A to mount all the devices mentioned under etc fstab, which is a mandatory thing. That is fine, fair enough. Now I just mount the device using the device name. If I show you the mount command, it is showing me up, and if I go inside mnt my data, I should be seeing my file hi, which is coming up here. Fair enough. Now another way of mounting is that by using the UUID. So I just do one thing. I go to etc fstab, I comment it out. I don't want this. Save and come out. I again give a mount all. Now if I give mount command, it is okay, because it was already mounted. I just do a u mount, and I just make sure that it is not mounted. Now it is not mounted. Now the another way of mounting is that I can use the UUID, unique identifier, using the device UUID, which I can see by using the blk id command or the block id command. The main benefit is that we use the, or if you see the fstab, even while installation, Red Hat has installed or mounted the device using the UUIDs. So the benefit of using the UUIDs is that in case you've got SATA hard disk or hot swappable hard disk and you change the slot, the numbering will not affect the name of the device. So I can just mention it here. While using the SATA or hot swappable devices, in case of change of slot, the etc fstab will not throw any errors, and it is recommended also to mount devices using the UUID. So let's check it out. So here I just give the command blkid and it gives me the block ID of all my devices. So I am interested in SDF5. If you remember, I had assigned the label, so the label is coming up here, but here in this case I am interested in this UUID. Just do a copy of this. It's very simple. Copy it, open your etc fstab file, paste it here, remove the quotes very carefully, and rest everything will remain the same. mnt my data ext4 defaults 1 2. That's it. Simple, fair enough. I give mount -a, all that is good. Mount command, it is showing me up. Again, if I go to mnt my data, I'll be getting my file. So the main benefit is that in case somebody has changed the slot or the cable, but you have mounted the device with the block ID, it won't affect you, or it won't throw you any error. While in case when you have mounted the device by the number and somebody had changed the slot of the device, say SDA will become SDB, if somebody had changed the slot, then it is definitely going to throw you the error. So it is how you can do this. There is as far as your RHCE is concerned, it is what you need to remember and learn very carefully. And but I'll just show you one more important thing, that there is another way also. Apart from mounting it with the device name and the block ID, there is a third way also. That is the way which is we normally, another way for addressing the devices is with a name that will never change, is to use the names in the dev disk. There is a folder there, dev disk. I'll show you what is stored here. Here the Linux kernel creates persistent names for all the devices, and we normally use it for SAN and iSCSIs, so not relevant at your stage. Normally used in SAN environments where we use iSCSI with iSCSI. But I'll just show you. Okay, if I go here, dev disk, see there, you can see 4 folders here. I just go to say by ID. Every hard disk SDF5 has got some number attached to it, and I'll just show you by path. By path is what we use in SAN with iSCSIs. Look here, and if I go to by UUID, sorry, here it is. All the device has got certain numbers associated with it. If you remember, if I just do a tail -3 etc fstab, see there, this is the same UUID number which you had taken from the blkid command. Got it? So, but as far as your RHCE is concerned, just focus up till here. Just putting a mark here, right here. It is something extra that you might be learning when you will be doing RSCSS and other things, or the clustering part or the iSCSI parts. So it is how you should be creating the partitions and the points that you should be remembering while creating the partitions. And as far as the partition is concerned, it's a very important topic for your production server environment or your daily lives, and as well as your practical exam is concerned. So I hope you will like the video, but remember, like friends, we intend to create these videos for the whole RHCE training, and they will be based on subscription model inspired by Red Hat. So so be ready for these elaborated videos and the things that you will be learning apart from your your normal training. Thank you very much. God bless. I'm Alok Srivastava signing off. Bye. Take care. Ciao. Stopping the video now.